So we're here today in the beautiful city of Pickering, Ontario at Worley Chemetics manufacturing site to inaugurate the expansion of the plant. Sitting with me today are Leonard, Group President, Technology Solutions at Worley, and Dan Blondal, CEO and founder of Nano. The two companies announced an alliance earlier this month to globally deploy Nano-One's patented technology for the production of cleaner and more competitive cathode active materials. So to you, Laura, can you just give me, first of all, an overview of Worley and the plant here and what's happening today?
Absolutely. So Worley is a global engineering, procurement, and construction company. And what that means is that we deliver capital projects for customers all around the world in the sectors of energy, chemicals, and resources. And what I do at Worley is I lead our technology solutions business, which is a process technology business within Worley, consisting of Comprimo and Chemetics today. Comprimo delivers technology for sulfur recovery, and Chemetics, the facility that we're in today, we deliver sulfuric acid technology and chlorine chemical technology. And both of those chemistries are highly corrosive services, and that's why we have the metallurgy expertise in the fabrication shop that we're celebrating today.
All right, thanks. And to you, Dan, can you give me a little overview of the technology, the Nano-One's one-pot technology?
Yeah, our one-pot technology is a process for making cathode active materials used in lithium-ion batteries. And just maybe to give everyone a sense of what that is, we combine lithium, nickel, manganese, cobalt, or lithium, iron, and phosphorus and other metals into a composite material that then stores energy. That's the functional material that goes into a lithium-ion battery that stores and delivers energy as you charge and discharge the battery. And our technology, our one-pot process, combines a series of processes that are used in the industry today into one to drive down the cost and the complexity, but also to drive down water usage, energy intensity, GHGs, and we completely eliminate the need for intermediate chemicals that actually end up in waste streams, such as sulfate and various other properties. And then by extension, that allows us to then diversify supply chains and bring more energy security essentially to the battery industry around the world.
Mm-hmm. So your motto is changing how the world makes battery materials. Why is change necessary in the world now?
As we look at net zero in 2050, people have kind of calculated that'll take 300 terawatt hours of batteries, installed batteries in various applications, be that in vehicles or storing energy for wind and solar. To make 300 terawatt hours of installed batteries, we'd probably need 500 million tons of cathode active materials. And to get there, we would have wasted probably somewhere between 1 billion and 2 billion tons of sodium sulfate. And we simply can't go there. We can't scale to that kind of a level and still have that problem. We are still in the nascency of this industry. And in order to get to those kind of volumes, we need to solve those problems. So that's really at the core of what we're trying to do. We're trying to solve the scalability problems that will allow us to deliver the batteries and the supply chains that can effectively meet those needs and do it in a sustainable way and do it as stewards of the environment.
So would you qualify your technology as disruptive?
Very, very much so, very disruptive, because the technology that's used today is largely grown up for the last 20, 30 years, starting in Asia. It's actually largely grown in Asia. It's grown from something that was small, and the waste streams and the byproducts and the downsides of that were all relatively small in scale. As we've made as the world has made these processes bigger and wider and deeper and longer and faster, those problems just have got bigger and bigger and bigger, and very hard to now export those processes into the West, into Canada, into the US, into Europe, and even into other jurisdictions in the Indo-Pacific region or into Australia without actually inheriting all of these very large-scale environmental issues. So we are trying to disrupt that, change how that works. We still need nickel, we still need iron, we still need lithium. The key is to pick pick sources of those materials in a form that doesn't then cause the environmental issues that I spoke of earlier. So, and that is a disruption to the supply chain. And disrupting the supply chain requires large partners like Worley really to help us execute on it, and that's how we all came together.
So the two companies decide to join forces and make an alliance, so Worley and Nano One. How does it align with your strategy, Laura, of Worley, and why is it important?
Yeah, our purpose at Worley is to deliver a more sustainable world. And so as we've looked at ways that we can take the transferable skill sets that we have in Worley and impact the energy transition, battery materials emerged as a few years ago as one of those key areas for us to focus, because what's needed for battery materials to come to market at the scale that Dan talked about is really a combination of the expertise we have in the resources sector with the expertise and the experience we have in the chemical sector. And so that's where our focus has been, is on how do we bring those skills we have in those two areas to bear on being able to enable new technologies in the battery material space.
And what are Worley's ambitions in battery materials, cathodes, battery industry at large? I mean, we see you've been very active, huge growth in that sector for Worley in the last few years, last 3 years more specifically. How would you explain that?
We recognize the synergy of our resources and chemicals expertise in specifically for battery materials as the need for more battery materials was emerging around the world. And so we moved early to position ourselves to be able to be the partner of choice to deploy technologies around the world and to execute projects. And so that's why you've seen our project delivery teams working on many projects that are already in progress.
And how is that partnership with Worley beneficial to Nano One? Why did you choose Worley to deploy your technology?
Yeah, I would say probably we didn't choose Worley. We came together and chose each other, very much so. I think we found ourselves obviously in the same neighborhood, at the same watering hole, and found, first of all, I think a very synergistic view of the world. We are trying to solve very large-scale problems simultaneously. Worley with the specific skill sets that Laura brought up, and Nano One with the technology that can really help enable that. The key thing is that we have technology that solves really the big environmental scaling issues and drives down cost and complexity, which of course is very important. And then what Worley brings to the table really is bench strength and in designing plants, in being able to modularize them and deliver them to many jurisdictions around the world, not necessarily one after the other, but often in parallel. We need to grow quickly. To grow quickly, we need a large team. We need a large sales team. We need large delivery teams. We need large engineering teams. And the concept that we came up with is this design once, build many concept. And I believe that's worked very favorably for you in your other, certainly in your other businesses. And it's new to battery materials, but the world's just really starting to wake up to that. So that's really that's a really important part of this, and I think the key thing that we bring to the table is that because we don't have any wastewater, we don't have any waste streams, it makes it much easier to modularize that. You can actually cookie cutter that out in many more places in the world than you can a conventional cathode plant, and that enables the design once part of the strategy. And
what Dan talked about with design one, build many is very well aligned with what we think is needed in capital project deployment to enable the energy transition. We've partnered with Princeton University over the past 3 years from a series of papers called From Ambition to Reality, where we identified 5 key shifts that are needed to enable net zero by 2050 to be a reality. And in the partnership that we have with Nano One, we're actually embodying 2 of those 5 shifts, where we talk about enabling technology options, recognizing the technology of the past can't get us to where we need to be in the future. And so we need to be a part of enabling technology options. And the Second one is standardization. That if you look at the quantum of capital that would be needed to get us to net zero, if we did things bespoke every time, it's mind-boggling. But one of the ways that we can bring down the cost of deployment and accelerate the pace of deployment of new technologies is standardizing, or design one, build many.
Mm-hmm. So how do you see, in your respective points of view, the impact of this partnership, both for Canada and for all of the world, really, because the goal is global, right?
Obviously, for Canada, I think it's really important. I've said this before. Canada has a history of being hewers of wood and drawers of water, as they say, basically focused on the resource industry and largely exporting our raw materials for processing elsewhere, only to buy them back as finished products. What we see in Canada here is an opportunity to build that midstream, build that secondary industry, basically the value add part of the industry, to feed not only, let's say, battery supply in Canada, but also to for our neighbors down south and for like-minded countries and free trading partners around the world. So that's a really important part of the opportunity that we see. And we can't do it by copying the existing process, as Laura said, because there's some fundamental scale-up issues there. So we have to solve those, and we have to invest in innovation. And that plays. I think Canada has always been a very strong innovator in those areas, and now being able to adopt that, to use it to build out industry in Canada is really important. But it doesn't stop there. Of course, that just becomes the springboard and the opportunity really to do the design once part. But then if we can build many around the world based on what we come up with here, it's certainly very, very important.
I look at it from a supply-demand perspective, that the electrification of our energy systems is going to increase the demand for the cathode active materials. And the gaps are particularly pronounced in North America and in Europe. And the one-pot process gives us an opportunity to have technology that solves some of the environmental hurdles that will make it challenging to deploy the older technology in those geographies.
So delving a little bit deeper into the design one, build many, can you give me examples of where it was beneficial for Worley, and where have you used that model?
So design one, build many will have a lot of benefits in project execution. It lets projects be executed on a faster schedule because you can skip parts of the front-end engineering because they're already done. It can also help with cost, not only because of the pre-designed engineering, but it will let us develop relationships and repeat business with vendors. And we see that in our existing businesses, that part of what makes Comedic successful today is that we have long-standing relationships with our key suppliers of key equipment and raw materials. And so that is one of the things that I expect we'll be able to do with Nano One, is to develop those supply chain relationships that help us to execute projects quickly, on budget, on schedule, and successful for our customers.
So we're only a few weeks into the Nano One Worley alliance. What are the next steps together on your path to commercializing the one-pot process?
We form the teams and basically who's going to communicate and everything with each other. But really the big steps are putting the early stage process engineering design packages together to go out and start marketing those to certainly our network, Worley's network, our combined network, looking to see what those opportunities look like, and then it moves into detailed design packages, which will define what the plant looks like ultimately for deployment in places around the world. So it's really just about starting to combine all of our know-how into these design packages, and that's not just the one-pot process and the IP. It's also what Worley brings to the table, Worley Comedics brings to the table. So that's key pieces of equipment, flow sheets, engineering design, and as much of the plant engineered, pre-engineered at once, kind of into this design package. That's really what we need to get to, and it's a process. It's a matter of months and kind of quarters basically till we get there. But those are the kind of timelines I think we're looking at.
I mean, I would echo the next 6 to 12 months is us working together to make sure we've dotted the I's and crossed the T's on that standard design so that we're ready to deploy quickly for our first customer. At the same time, we're really excited to be able to start talking to customers together and finding the end users who want to collaborate with Worley and Nano One to be the first user of the technology.
Yeah, and even before we have the package ready, we were just talking earlier about sort of synergies we have in our relationships that are already leading to sort of incoming inquiries. So a lot of really positive things are already starting to unfold for us. And you know, if we can bring this kind of package to the market, as you said, it really does help accelerate so many things. It accelerates also the financial decisions. It de-risks many of the financial decisions that let's say project lenders or large companies with big treasuries have to make before they commit to a project. But having that all done up front is super important to the acceleration, the wide-scale adoption of the technology.
Yeah, so I really hope the next time Dan and I are sitting down together that we have a customer at the table with us, that we're able to have that discussion with our customers.
Sounds good. So any final thoughts on kind of what's coming up in the future between Nano One and Worley? Final comment on what's happening and what's going to happen next few years?
We're certainly looking forward to that for those first customer discussions, and I think those will actually come into focus very quickly. And then it's all about getting them across the line and executing on those first projects. I think once the ball is rolling, we have a lot of the pieces in place here. We have the technology, we obviously have the Worley platform, and we have a really an open and willing customer pipeline around the world, not just in Canada, but around the world. And really, those final pieces are all coming into place right now as demand builds in the West for locally produced cathode materials with diversified supply chains. We're going to see this thing, I think, really take off, and that's to me what it's going to be very exciting. But it's going to grow and grow and grow, and that's what I expect to see.
Absolutely. I mean, I think we're really well positioned to change the world by delivering a more sustainable world together.
Mm-hmm. Sounds good. Well, I'm sure this is the beginning of a great story for the two companies together and for the battery industry as a whole. Congrats to both on the alliance. Congrats specifically to Worley for the plant expansion here, and wish you both resounding success in the near future and long-term future.